Hello everyone, I'm Teacher Al. Welcome to my channel. Okay, today we are going to study distance problem for grade 7. Okay, we have now number 2 problem. Mr. Rivera headed south driving his car 60 kilometers per hour. After 30 minutes, his son followed driving another car at a rate of 70 kilometers per hour. How long will it take Mr. Rivera's son to overtake him? So this problem asking for the time to overtake Mr. Rivera's sons. Okay, our solution, we have to pick up first the given. The given Mr. Rivera rate is 60 kilometers per hour plus 1/2 hours. Then sun rate is 70 kilometers per hour. Our representation, let x be the time traveled of the sun, and then x plus 1/2 be the time traveled of Mr. Rivera. And our equation, distance traveled of Mr. Rivera is equals to distance traveled of the sun. To solve the equation, since we have the distance is equals to RT, and equals to RT. Then we have to substitute the rate of the Mr. Rivera is 60, and the time covered by Mr. Rivera is x plus 1/2 equals the rate of the sun is 70 times x. We use x because the time travel of the sun is x. Okay, then next is we're going to simplify. We will use the distributive property. 60 times x equals 60x. 60 times 1 equals 60 divided by t equals 30 equals 70x. And then we have to transpose all the variable to the left side of the equation and the constant to the right side of the equation. Okay, 6x, then 70x transposed to the left side of the equation becomes negative 70x equals the positive 30 becomes now negative 30, because when we transpose we're going to change the sign. And now next is to simplify. 6x minus 70x equals negative 10x equals negative 30. Okay, we're going to divide both sides by negative 10, and our x now is negative 10x divided by negative 10 equals x equals negative 30 divided by negative 10 equals 3. So therefore, the time travel covered by the sun is 3 hours. Our complete answer, 3 hours times of sun to overtake Mr. Rivera. Okay, we have another problem. Carla is driving 50 kilometers per hour. How far will she travel in 4 hours? Letter A. B 6.5 hours, and C 20 minutes, and D 1 minute. So the problem now asking what is the travel time? What is the distance covered? If for letter A, the hours is 4 hours. Okay, we will use our solution. We will use D equals RT for letter A. Then the given the rate is 50 kilometers per hour. Then we are going to multiply by time, which is 4 hours covered in letter A. Then 50 times 4, we're going to multiply, becomes 20 kilometers per hour, the distance covered by letter A. For letter B, we have the same formula that we're going to use. D equals RT equals 50 again, the rate kilometers per hour given. Then the time covered is 6.5. Then we're going to distributive we are going to multiply 50, then the 6.5, this is mixed number, we will change this to improper fraction. Then we're going to multiply 50 times 13 divided by 2. So the result is 325 kilometers is the distance for letter B. And for letter C, D equals RT again, our formula. Then the same kilometers per hour, covered is 50, and 20 minutes, it's about to divide by 60 because our rate is and state and hour. That's why we're going to divide it by 60 minutes. So our to simplify now, 50 times 200 divided by 60, we have 1060. Then 1000 divided by 60, we have 16.67 kilometers covered on letter C. Okay, letter D. Letter D, we have the same formula that we're going to use. D equals RT, then equals the same rate, 50 kilometers, and the time is Y. So our since Y is minutes, so we're going to divide it by 60. So then we're going to multiply 50 times Y divided by 60. So our answer is 50Y over 60, then we're going to divide it by 10. So that's why our final answer is 50 over 6Y kilometers. That's for letter D. About measurement of arc, angle of secants, and tangents. First, we have to observe the given circle and lines. We have secants here, secants line, and intersecting each other, and angle formed inside the circle, this angle 1. And if we're going to get the measure of this angle 1, we're going to use the formula measure of angle 1 equals to 1/2 of the arc 1, which is the big angle arc, and plus the arc 2, which is the small arc, this one. And we have another example. We have here the circle and the secants intersecting on the circle here and form an angle 1. And to find the measure of this angle, we have measure of angle 1 equals 1/2 of the intersected arc. So 1/2 of this arc is the measurement of this angle 1. And the next figure is the circle and the secant lines intersect each other and form angle outside of the circle. This angle 1 here. The measurement, to get the measure of angle 1 is we have the formula. Measure of angle 1 equals 1/2 of the big arc, which 1, then minus the small arc in this arc. Another example, we have here the circle and tangent, and another tangent intersecting outside of the circle and form an angle. This one is angle 1. And how to find this angle 1? We have also measure of angle 1 equals 1/2 big arc is 1 minus the small arc. So the result will be the measure of angle 1. Another example, we have secant intersecting the tangent line and form angle outside of the circle, and this is called angle 1. To find the measure of angle 1, we have measure of angle 1 equals 1/2 the big arc is 1 minus the small arc equals the measure of angle 1. Okay, we have an example number 1 here to apply the formula. Find the measure of angle 1. First, we have to analyze the given figure, which is the circle and the two secant lines intersecting each other and form an angle inside the circle, not on the center. So this is not the problem. We're going to find the measure of this angle. To find the measure of this angle 1, we're going to use the measure of angle 1 equals 1/2 the sum of the two arcs between the BC and the ED. So we have 20 and 30, we're going to add this. So 20 plus 30 equals 50 times 1 equals 50 over 2. Then 50 divided by 2 equals 25 degrees. So therefore, the measure of angle 1 is equals to 25. Next, number 2. Find the measure or arc BC. So this one, what is the measure of this arc BC? So our formula is measure of arc BC equals the angle 40 times 2, then minus this arc 60, and 40 times 2 equals 80 minus 60 equals 20 degrees. So therefore, the measure of angle BC is 20 degrees. Next, number 3, find the measure of angle 1. So here, we are going to observe first the given. We have circle and the two secants intersect each other and form an angle outside of the circle. And the given, the small arc here is 30 degrees and the big arc is 120 degrees. We are going to find the measure of angle 1. We have the formula, measure of angle 1 equals 1/2. We have to subtract or minus 120 minus 30. So 120 minus 30 equals 90. Then times 1 equals 90 over 2. Then divided by 90 over 2 equals 45 degrees. So therefore, the measurement of this angle, this is measure of angle 1, equals 45 degrees. Next, number 4, find the measure of big intersected arc. So, in this figure, we have circle, we have two secant intersecting each other outside of the circle, and the measure of this angle is 40 degrees, and this small arc here is 20 degrees, and the problem is, what is the measure of the big arc? So our formula, the measure of the big arc is equals to, we have to multiply by 2 the angle here, 40, so 40 times 2, then plus the small arc, 20. Then 40 times 2 equals 80, plus 20 equals 100 degrees. So therefore, the measurement of the big arc, this one, is 180 degrees.